Welcome back. This is going to cover the MRS22 Spring 2023 final part 2, the multiple choice section, questions 25 and hopefully 26 and 27 if I can get them all done in one video. See how that goes. So let's begin with 25. Write the simplified expression for the summation 4 plus from k equals 2 to 5, 3 times k minus x. So we're going to see in this case that we're going to be plugging in the number 2, plug numbers 2, 3, 4, and then 5 into this expression of 3 times k minus x. And then afterwards add the 4. So let's plug in the values of 2, 3, 4, and 5 because we're starting off with 2, that's the lower number, the lower limit we call it, and the top number is upper limit. And so we're plugging in the integers from 2 to 5. Now, very important that they go to k, not to x. So x will just be something we add on along the way. So when k equals 2, we have 3 times 2 minus x. And then we're going to add, plug in 3 for k, 3 times 3 minus x. And plug in 4 for k, 3 times 4 minus x. And finally, plug in 5 for k, 3 times 5 minus x. So we distribute the 3 and we get 6 minus 3x and 9 minus 3x, 12 minus 3x, and 15 minus 3x. Because remember, distributing means we're going to be multiplying both terms inside parentheses by 3. And now we're going to add all of this here. So we have negative 3x plus negative 3x plus negative 3x plus negative 3x is negative 12x. And 6 plus 9 plus 12 plus 15, well, 6 plus 9 is 15, 15 is 30, and in this case, 30 plus 12 is 42. But we can't forget this plus 4, right? So now we take 4 plus the 42 minus 12x, and we get 46. Oops, don't forget the x there. 46 minus 12x. And in this case, that gives us choice A. All right. So for summations, whenever you see summations here, the lower number goes into the variable that we see in this corner here. Notice that it's k, not x, and not both of them, right? X just kind of carries along. We only fill in with the letter, in this case, underneath the sigma notation. Number 26. A standardized test with a normal distribution of scores has a mean score of 43 and a standard deviation of 6.3. Which range should contain the score of a student in the 90th percentile? Okay, so we're looking for the 90th percentile, and we're probably going to look for a particular score. When we do this here, we normally use, in this case, something called inverse norm. Okay, so in this case, we see the mean is 43 and a standard deviation of 6.3. And the area we're covering is the 90th percentile. So this is a normal distribution. It's kind of like a what they call a bell curve here. And so here's our mean. We want to figure out in this case what score in this case is going to give us this 90 percentile, 90% here. Okay, and so what we're going to do here is we're going to kind of fill in an inverse norm. So we'll grab a calculator here. Let's make sure I record some important information here. All right, so let's pull out a calculator. And so to use inverse norm, we go to second vars, which is distribution. And so whenever we want to find an area, we use normal CDF, choice 2. When we want to find a particular score, we use inverse norm, choice 3. Okay, so the area we're looking for is 90% or 0.9. Okay, 9% or 0.9. And our mean is that little symbol there. That's going to be the same thing as our mean. And our mean is 63. And a little symbol that's the letter B knocked over, That's our standard deviation, which we know as 6.3. Now, some of you on your calculators will have left, right, and center. We're going for the left because we're covering everything from 9% all the way to the left. All right. Now, if you don't have this option, don't you worry. Okay. Most time the assumption is it will be on the left. So we go down to paste, hit enter, and you should have in this case 0.9, comma 63, comma 6.3. And sometimes you don't have the left and everything. Sometimes it's parenthesis if you have an older calculator. Okay. We hit enter, and our score looks like in this case 71. All right, a score of 71.073, but you know what? Let's put 71 here because that's the score we're looking for. Okay, so inverse norm is used to help us find a numerical value, and so a score about 71 would represent the 90th percentile on this standardized test. So score of 71. Oh, maybe I typed in the wrong information. Maybe that's what happened here because I don't see that. Let's go back to calculator. All right. Oh, I know what happened. I know what happened. I put in 63 for the mean. And this is where we have to double check and see. So ladies and gentlemen, I'm going to just redo this. Second vars, choice 3. And this happens to double check here. It should be 43 for the mean. And some of you guys saying, it wasn't the mean 43? Yes, it was. Another make mistake. Sorry about that. Okay. So we hit enter. This should work out fine. Our score is 51. That makes a lot more sense. 51 makes a lot more sense for our score. Okay, so let's go back to here. Now 51 looks like it belongs in the range of 49.3 to 55.6. So we have a score of 51. 51 belongs in choice B. Okay, so yeah. But in general, double check. Always double check your work. Sometimes use calculator. We got to make sure we're typing the right things. Okay. All right. Now for question number 27. A linear regression equation of best fit between the hours a student spends on homework and studying and the degree of success in school is 2x plus 80 equals y. This is a linear regression, meaning this is the line of best fit that comes from your data or scatter plot. The correlation coefficient R for this data would be, and now we have, in this case, what would the R value be? Well, very important to keep in mind that we take a look at our equation here. I'll rewrite as y equals 2x plus 80, because that's what we normally see here. And we'll focus on the slope. Remember, the slope of the line is going to be the value multiplying x after we get y by itself. So our slope will be 2. More importantly, positive 2. Now the sign is important for us, okay? Because the sign of the slope is the same as the sign of R. The sign of the slope is the same as sign of R. So if I have a positive slope, I have what's called a positive correlation, meaning as one value goes up, the other one goes up with it. So R value be a positive value. If I have a negative slope, that means the two values are moving in opposite directions to each other, meaning a negative R value. So one value goes up, the other one goes down. So since our slope is positive, I'm looking for R value is positive. And that would be choice A. Okay? And so that's sort of here what we have to kind of figure out in this case, what the value of R would be. And of course, now if they had more than one choice of positive R, we'd have some trouble here because the R value is closer to 1 if the correlation is really good, meaning the values of data really fit close to the line. All right, and the closer you get to 0.99999, that's really getting a good fit and all. Or negative 0.9999, because the negative number close to R value close to -1 will be also an extremely excellent correlation as well. Okay, so these were the questions are requested on Google Classroom, and so I figured, hey, I do these questions here, and so hopefully this is helpful to you guys. Definitely review and go over the questions in our part 2 final. Part 2 is all multiple choice, so bring those number 2 pencils. Good luck, everybody. All right, and I hope this was helpful. If you found it helpful, all right, if you want to watch it again, please watch it again. Have comments or questions, leave them in the comment section below. And if you found this helpful at all, give it a like. And if you have not subscribed yet, please subscribe. In the comment section, please also include any topics you want to cover further, because you know what, this is a final for Algebra 2, and as you go on to your next level class of pre-calculus, there will be some overlaps, and if you want me to go over any particular topics, just let me know. It'd be great. Thank you so much, everybody, and I hope you guys do well. Good luck, take care, and be safe.